right, today we're going to look at properties of exponents. Hopefully this is good review for you from the previous 2 years. We are looking at properties of exponents as we get ready to move into exponential functions. All right, so today you need to be able to explain the meaning of zero and negative exponents. You need to be able to evaluate and simplify expressions involving zero and negative exponents, and you need to be able to simplify expressions using properties of exponents. All right, the properties that you must know. All right, the zero exponent. For any non-zero number a to the 0 equals 1. So this is saying basically anything to the 0 power equals 1. The power of 0 to the 0 power is undefined. But examples, 4 to the 0 power equals 1. 10 to the 0 power equals 1. Anything to the 0 power equals 1 except 0 itself. All right, a negative exponent. For any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. Example, 4 to the negative 2. That equals 1 over 4 squared. So it becomes the reciprocal when the exponent becomes positive. Algebraically, a just represents any number. A to the negative n equals 1 over a to the n power. All right, product of powers property. Let a be a real number and let m and n be integers. All right, so product means multiply. So if you have 4 to the 6th times 4 to the 3rd, you can keep your base and add your exponents. That's basically what this is saying. When you're multiplying with the same base, you're going to add your exponents. So 6 plus 3 becomes 9. So that would be 4 to the 9th power. Algebraically, a to the m times a to the n equals a raised to the m plus n power. Quotient means divide. All right, so let a be a non-zero real number and let m and n be integers. To divide powers with the same base, subtract their exponents. Okay, product powers, same base. Quotient powers, same base. It's important to remember that you do have to have the same base. All right, so if you have 4 to the 6th divided by 4 to the 3rd, keep the base, subtract your exponents when you divide. So it'd be 4, 6 minus 3, you always subtract from top to bottom. Algebraically, a to the m over a to the n equals a to the m minus n power, where a is not equal to 0. All right, power of a power. All right, so this is talking about exponents. Let a be a real number and let m and n be integers. To find a power of a power, multiply the exponents. All right, so if you have one base and 2 exponents, that's a power of a power. So you would multiply the 6 times the 3. So 4 to the 18th power here. Algebraically, a to the m raised to the n power. This is a power to a power equals a to the m times n power. All right, last two, a power of a product property. All right, let a and b be real numbers and let m be an integer. To find the power of a product, find the power of each factor and multiply. 3 times 2 raised to the 5th power. You can put each number raised to that exponent. I want to say distributive property. It's not distributive property, but you are distributing the 5, the exponent, to everything inside the parentheses. All right, so algebraically, you've got a times b raised to the m power. That's the same thing as a to the m times b to the m power. A power of a quotient property, let a and b be real numbers with b not equal to 0 and m an integer. To find the power of a quotient, find the power of a numerator and the power of the denominator. So here you have 3 halves raised to the 5th power. That's the same thing as 3 to the 5th over 2 to the 5th. Algebraically, if you have a over b to the m power, that's the same thing as a to the m divided by b to the m. Remember, when you divide, your denominator cannot equal 0. So that's why this says where b is not equal to 0. All right, let's test out these properties. So Example 1 says evaluate the expression. We've got 6.7 to the 0 power. Remember, anything to the 0 power equals 1. Here we have negative 2 in parentheses raised to the negative 4 power. When you have a negative 4 power, that means you've got to do the reciprocal. So it's going to be 1 over negative 2 to the 4th power. All right, negative 2 to the 4th power is the same thing as negative 2 times negative 2 times negative 2 times negative 2. So that's going to be 1 over 16. All right, example 2, simplify the expression 4 times x to the 0 power over y to the negative 3. Write your answer using only positive exponents. All right, so we've got 4 times x to the 0 power. X to the 0 power is just 1. And then if we have y, it's over y to the negative 3. So we're going to bring that up, and that's going to be y to the 3rd power. So 4 times 1 is 4. Y to the 3rd is the simplified answer for number 2. All right, again, we are just using the definitions of properties of exponents. All right, self-assessment. All right, I want you to take time and try to do these. There's 4 examples right here using properties of exponents. See if you can simplify those quickly. Then I want you to look at number 5. Your friend claims that 1 over a to the negative n power equals a to the n, a times n. Is your friend correct? Explain your reasoning. Simplify the expression. Write your answers using only positive exponents. So there's 4 more examples here that you need to simplify. Just pause the video, work these out, see how you do, and come back to see if you get the correct answers. All right, hopefully you took time to look at these. Number 1 is 1. Number 2 is 1 over 27. Number 3 is 1 over 1,000. Number 4 is negative 4. All right, this one's a little bit tricky. This one says negative times 5 to the 0 power. The negative 5 is not in parentheses, so that means only 5 to the 0 is what you're looking at to evaluate as 1. So the negative comes down. 5 to the 0 is 1, so that's negative 1, over 2 to the negative 2. Then you bring this up. Negative 1 times 2 squared is 4. Negative 1 times 4 is negative 4. All right, number 5, your friend claims that 1 over a to the negative n equals a times n. Is your friend correct? No. It should be a raised to the nth power, not a times n. All right, number 6, 1 over m cubed. Number 7 would be 16w. Number 8 would be 1 over 9x to the 5th. Number 9 is q to the 3rd divided by 64 r to the 5th power. This is a great way to practice as you are learning or reviewing, so this helps keep these skills fresh. So hopefully you got those correct. If you have any questions, please let me know. All right, example 3, simplify each expression. Write your answer using only positive exponents. So what they're wanting us to do here is just show that we know how to use the properties. All right, so here we have 3 squared times 3 to the 6th, same base. When I'm multiplying, I add exponents. So I'm going to show that I have 3, 2 plus 6 is 8, so 3 to the 8th power. If you want to evaluate 3 to the 8th, that's fine. But right here, they just want you showing that you can simplify and leave it with positive exponents. All right, here I have a quotient property. So same base, I subtract from top to bottom. So I'm going to have negative 4, 2 minus 7. So negative 4, 2 minus 7 is negative 5. It says use only positive exponents. So I'm going to rewrite this as 1 over negative 4 to the 5th power. Again, you can simplify this since it is numbers, but what they want is for us to show that you know how to use the property of exponents. Here we have a power to a power. All right, so when we have a power to a power, or power of a power, we are going to multiply the power. So I'm going to have z 4 times -3. 4 times -3 is -12. Again, we want only positive exponents, so 1 over z to the 12th power. All right, example 4, we're looking at some more properties of exponents. It says simplify each expression, write your answer using only positive exponents. So we have a power of a product meaning we're multiplying again. So we're going to do both numbers on the inside raised to the power. Now, since this is a number, we can go ahead and evaluate -1.5 squared. Remember, anything squared is positive. -1.5 squared is going to be 2.25. And then y squared comes down with it. All right, so this time I have a power of a quotient. And again, when I have a power of a quotient, we recognize this because this is in parentheses. The whole thing is raised to the third power. All right, so we're going to have a to the third over -10 to the third. And then we can simplify that as a to the third. And -10 to the third would be -1000. All right, see, you have a product and a quotient. You have 3d divided by 2 raised to the 4th power. So that means everything inside the parentheses is going to be raised to that 4th power. So we're going to have 3 to the 4th, d to the 4th over 2 to the 4th. And again, we can simplify the numbers here. All right, so 3 to the 4th power is 81. And 2 to the 4th power is 16. All right, and then if that reduces, you could reduce the numbers, but this does not reduce, so we can leave it as it is. All right, so again, we have a product and quotient together, so we have 2x divided by 3, all raised to -5. So the first thing we want to do is do the reciprocal of this, so this becomes positive. All right, so we're going to change this to 3 over 2x. And now when we do the reciprocal, that's a positive exponent. All right, so now we're going to have 3 to the 5th over 2 to the 5th and x to the 5th. All right, so 3 to the 5th power is 243. 2 raised to the 5th power is 32 times x to the 5th.